All right, so now that we have our PCB designed, we can start building our case. And we said in the previous video that it was going to be around 9.5, 7.5. So we can start with that. We're going to use something called variables to help us modify everything because many parts are going to be have like that same, what's the word? The parameter. Actually, the word would be parameter. Don't worry, we're gonna start and you're gonna understand what I'm talking about. So I'm gonna create a new part, create new part studio. Let's call these the let's start with the bottom. Let's call these the bottom, uh, bottom, or we can call it case bottom. Case bottom. Oh, I got it. Great. And case bottom is gonna start super simple in top, um, and we're gonna have these general rectangle that is gonna be the dimensions that I just said, which is, well, okay, so before we start, I'm gonna put the two dimensions here. I'm gonna go here to variable table, custom table, here, variable table, create variable studio, create variable studio. I think this is the one. Oh, no, I want variable studio 1. I think I did this once and I don't know how to delete it. But variable studio, insert variable studio. Anyway, I'm pretty sure it's here, variable studio 1. Um, so we're gonna call these case underscore width, and we're gonna make another one called case underscore length. All right. Um, width we said it was gonna be 6.5. No, sorry, 6.5. Well, 65. Better said. Uh, millimeters, yeah. And here we're gonna do 95 millimeters. All right. Now, I just want to prove a point here to make sure I'm using this right. Uh, but it's that instead of writing 11679 whatever, I'm gonna write hashtag. Oh, there they are. Length, and instead of writing 80 whatever, I do hashtag case width. Now you might think, well, what's the point? I mean, just write the number. Like, why are you doing that? Well, um, you'll see in a minute. I'm gonna extrude to bottom because that's like this is one part of the case, right? Um, I'm gonna move these later, but just to prove my point, I'm gonna make a new part. Create part studio, but this part is gonna be extruded to the. Oh, I mean, actually, that doesn't matter. My point is, I want to make a drawing because this is gonna be the case top, but because I want it to fit with the other one, I'm going to do here hashtag, and there they are. So I can access them throughout the whole document. Length. Now, because the bottom and the top are gonna be different, but some things are gonna be the same. That's why I'm doing this. Like if you see the parts, like I have this one is different than this one, but they share the same width and the same length, if that makes sense. So this is gonna be called case top. I'm gonna extrude. Yeah, I'm gonna modify this, whatever. These two are gonna be able to fit. That's the whole point here. Yeah, so the extrusion, that's a good point. Like how I think that's a good point. So it has to fit a battery. Oh my God, I forgot to model. Let's model the battery super quick. I forgot. We should have the battery somewhere, and we should have a solution for changing the battery though. Ooh, that's interesting. I mean, I guess you can disassemble the whole thing. I mean, that's not the best solution, but I mean, complexity wise, I think it just makes sense for now to have like that. I mean, you can put a lid, you can put a little hinge. There's many things, but for now, I think you just need to disassemble it um, to change the battery. Um, yeah, that's the one. I didn't thought about that. We can make a lid. Let's just do it like that for now. Then we can figure out something else. But for now, then we can put a lid or something that comes off. Yeah. Yeah, I'm picturing that right now. All right. So I need my caliper. I thought I was not gonna be using it anymore, but I was wrong. I do have to use it. Actually, I do have a let me just turn on my camera because I have this battery and I have this little like connector that goes in. And so I would rather take the measurement with the whole thing, you know, because it matters. So let's just get the measurement of like, you'll get it when I'm doing it, but let's see, 45, I'm just gonna make a drawing here. So that's 45, 43. 2583. And 1711. And then we have like this other little rectangle coming out of it, which is gonna be just a bit slower. Sorry, smaller. So it's I need center. 1261. And 2414. Yeah. All right. Oh, the height. Seven. All right. Now that I have the measurements, I can get rid of this camera. Oh, no. Change here. All right. Cool. I'm gonna have to make a new part. Create part studio. Yeah. I'm gonna call these 9 volt battery with connector. And so I'm gonna go to top. Well, do it in right. It doesn't matter actually, but I just like doing it like in the like the direction it is being used. So I'm gonna make just here to here. I'm gonna go to right, and I'm going to do the dimensions from here to here. That's 1711. And then here to here, that's 2583. And then I can extrude 45, 43. We can do this symmetric, and then I can go to the top here, new sketch. Uh-huh. 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 2414. 1261. And then I can extrude 7. All right, that's not a battery, but resembles the dimensions of a battery. All right, so considering that the battery goes on the bottom and that the battery is 17, so like that's a little thing that we could do here in assembly actually. So like if we line things up in our so this is the case bottom, this is the one. What we want to figure out is how much should I extrude it. Well, I mean, the Arduino is going to be on the bottom. I think I want to enclose everything pretty much in the bottom and the top for it just to be a lid. That would make things easy. But also this is gonna have to have this, like at least for the head of the bolt and these acrylic cuts. So maybe they can enclose these, just the LEDs, but we can work towards having the PCB board being flushed with everything here, the PCB board. We could do that. So if that's the case, I'm gonna make some like annotations, but the battery itself sitting, it's 1711, and then if that's touching the Arduino case, that would mean that the Arduino case is, I don't know, maybe 2 millimeters, maybe a bit thicker, maybe 2.5. Yeah, I think 2.5 is good. And then we have the Arduino, which is gonna be like there, which is from the Arduino to the other end of the PCB. Let's see. I'm gonna go here, from here to here. We can use that. We can measure with this tool. We can see the lines. Like that's the cool thing about here. We can measure things. So it's 1339. So the Arduino with the PCB, that's 1339. So if that's the case, and if we want all of that enclosed, we could even enclose the LEDs, just saying, but I don't know if we want that, because actually maybe we do want that. So if that's the case, so just on the top we have the acrylics. Yeah, I think we want that. So let's do everything. So instead of 1339, we're gonna go all the way to the top of the LED, and that would mean that I would have to measure from here to here 2239. 2239. So now if I go to the bottom, the extrusion is gonna be 2239 plus, we can do operations here, 17.5 4 plus 2.5 of the case plus, and I would give us maybe 1 millimeter of just like security. Just, I mean, you know what I mean? Just like to don't have everything like so pressed against each other. Um, tolerance, tolerance. That's the word. All right, that's a deep case. Oh my god, that's too deep. I don't know if I want it like that. I don't know if I want the LEDs here. I mean, we can change it later. I just don't like everything being so buried. I don't know how to say it. But you get my point. Oh, look, my variables. Cool. They're there. You know what? No, change my mind. Sorry. I'm sorry. Let's go to PCB. Let's measure this again. It was from here to here, 1339. I'm gonna go to this bottom. And the cool thing here, if I remember correctly, oh no. Oh, there it is. You can modify like everything. How is it that we go from 1339 to 2239 if the LEDs, oh, because they're not 5. I don't know why I thought they were 5. So it would be 13.39. Yeah, sorry, no LEDs enclosed. No. Now, I'm going to make it hollow. So I'm going to use a tool called shell, in which you say which face you want to remove, in this case. Well, but before we do that, I do want to make a bit of like a fillet in all these face, because that matters for the shell. So 3 millimeters. Let's go a bit deeper. Maybe 4. Yeah, 4 is good. All right. Great. Oh wait. No. I do wanna fillet, but I wanna fillet like this edge, 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 and this whole face. There we go. So 4. You know what? Instead of 4, I'm thinking of going here and saying general underscore fillet, so I can change it over time. Length, can I change this? Angle number, no. All right, case bottom. And in here, instead of 4, I do hashtag general fillet. So I want to change it everywhere, also in the top part. I can just do that. All right, there we go. Now I can do the shell. I can click here, and now as you can see, it's empty. Oh, 2.5. All right, good. That's what I wanted. Good. Oh my God, we're getting there. Dang it. Now the case top is gonna have like a similar situation. So the height of the top is gonna enclose the LED, just the LED, which is the difference between 22 and 13, 9. Yeah, 9. Plus some acrylic. Well, but the acrylic can be enclosed in the plastic. So not really, but maybe the plastic has to be maybe just a bit thicker. Because 2.5. Okay, so how thin of an acrylic we can get? 1/16. What the heck is 1/16, by the way? 116 inches to millimeters. 1.5. I think this is gonna end up being like a 3. Oh, sorry. I mean, something else we have to consider is the fact that, let's see if Amazon sells acrylic 116 red. Buy plastic red 1/4. No, it's too much. 1/16. 4 pieces of red translucent acrylic, 3 by 3 inches. Well, it is small, and it's not precisely what I'm looking for because I want it to be transparent actually. 1/4, that's too much. Okay, how about 1/8? Red transparent acrylic plastic. Yeah, that's the one. Look, red transparent. Oh, but the date's too long. Monday. I like this. But I just want red. Red acrylic transparent. 1/8. Alright. Oh. Can you sort out? Alright, I'm gonna find that. Give me 1 second. Okay, sorry. But yeah, I figured out, you know what? 1/8 acrylic is way easier to get and faster. So we're gonna use that. So we have 9 millimeters of the LED, 3 of the acrylic, and 2 just for an extra layer to support. You'll see what I mean later on. But yeah, so this extrusion is gonna be the sum of all that. So and then a bit of a tolerance, of course. So it's gonna be 9 of the LED plus maybe 1 for distance and safety and tolerance, plus, you know what, maybe 2 of tolerance, plus 3 of the acrylic, plus 2 of plastic. All right, now here comes something different. Check this out. I'm gonna use this. Well, first of all, I'm gonna use the fillet tool, and we already have a variable going on. Remember? There we go. And instead of 4, we're gonna use hashtag general fillet. There we go. And then I'm gonna do what am I gonna do? Oh, I'm gonna do the shell. But the shell usually has a feature. No, it doesn't have a feature right now. That's a bit of a bummer. In which you can make one part thicker than the others. So that would have been appreciated here. Okay, got it. If that's not possible, then instead of a shell, I'm gonna have to do it by hand, which means making a new sketch, grabbing, well, picking all these lines, right? All these lines, and then saying offset offset, where's offset? Here's offset to the inside. Yes, and I can modify this number to 2.5. And then I'm gonna cut. Oh, it's not gonna be the same though. Well, I mean, it's gonna be fine. I'm gonna cut, solid, remove, and I want to do it just 5 millimeters away from here, because that's what I need. So it's not like a proportional hollow, if that makes sense. But I don't remember the number, so I'm just gonna do it, and then I'm gonna go to extrude. We have 16, that's what it was. So in here I should do 11. 11. So we have 5 millimeters here to have 3 of the acrylic plus 2 of plastic. Or maybe 1 of plastic. Yeah, I think we should do that. 1 of plastic. Well, let's just do it like that for now. 2 millimeters in the acrylic. Would that look bad? No, I don't think it would look bad. Let's just go safe. All right, that's that. Now, that's done. Now, all right. So I would suggest we start trying. Well, how much time has it been? All right, 26 minutes. All right. So we have part of the case top, part of the case bottom. They're gonna be one top of the other. We have the PCB, we have the battery. Actually, I think we can start putting it all together and just getting a feel of how it's looking. So I'm gonna start in here. Here you have an assembly. Go there, and you're gonna start bringing things over. So for example, I'm gonna bring the PCB. I'm gonna try to put it here in the center. I'm gonna right click on it, and I'm gonna say fix. So this is the main part that's not gonna move. And everything else I do is gonna be like around this part. So for example, case bottom, I'm gonna bring it and I'm gonna put it right like trying to enclose this thing. So maybe something's wrong. Oh my God, that's not fitting at all. That's why this is important. So, well, as you can see, I'm missing some width, which is weird because I did. Oh, I think I messed up. Let's go to the variables. 65. It was supposed to be 75. But the cool thing, and to prove my point, if I do 75, it's gonna modify both my bottom and my top. So now I don't have to go in each one and change it. So now look at that. Ha ha ha. Oh my God, this seemed like I planned for it, but I didn't. Just so you know. Now, I need to so let's see, from here to here, we have 70, right? All right, cool. And from here to here, we know it's 60. So we can start doing like mates, that's the name, to start putting things like in place. So for example, like parallel mate, no, there's one called planar. So we can say, hey, planar, this with this. And that's gonna make them stay in the same plane. That's cool. Now it's restricted the movement a bit. We can say distance. Is there a distance one? Parallel from here to here, but limit minimum. What if I say 5 and 5? That work? Nope, didn't work. All right. So if one didn't work, you can just delete it. Oh, this is the one that I did. Oh, because I set in X. Oh, maybe it did work. All right, let me try again. But okay, so Y. What I needed was Y. My bad. I'm gonna say, hey, you and you, yes, be parallel, but we need a limit in Y. Let's do minimum 5. Oh my god, you're not understanding what I need. Nope. Nope, that's not what I want. Edit 5, maximum 5. Can I do that? But that's not why. Oh, why are you thinking why is that? This Z. Oh, okay, so maybe. All right, I'm gonna try to follow the rules of this game. Z, let's do 5 and 5. So maybe maximum. All right, what if I go here 5? Oh my god, how can this be so hard? I just want you to get away 5 from it. Minimum 5. That's 10. Negative 10. Oh, negative. Oh. So, maximum minus 5. There you go. There you go. No. Oh my god. Oh, there it is. It's not letting me go for, like, closer. Ah, interesting. Okay, so here I'm gonna go minus 5 as well. Let's see if that works. All right, it's set into place. I don't know why it's letting me move up and down if they're supposed to be planar. Like, aren't you working? Huh? Anyway. Oh, there it is. It's like glitching. That's good. All right, now I'm gonna do parallel from here. Look, the X, that's the red one, to here. Limit. I just want to make sure I'm in the right. Oh, it's Z. I don't know why it's Z always. So let's do 5. No, it's gonna be minus 5. And minus 5. All right, cool. Look at that. All fixed in place. So now it's not moving. Yes, that's what you want. You want to keep it out, not moving. All right, good. Something cool you can do. Well, I'm gonna insert something here. I'm gonna insert the battery just to make sure it fits. Now I cannot see. Something you can do here is click here and go to. What time is it? Okay, we're good. Here is it shaded with just translucent. Look at that. Look at that. Ain't that cool? It is cool. Oh my god. Oh yeah, it is fitting. Like, this is not the end line, this is the end line. So yeah, it fits. Nice. We did a good job. Oh my god. This is something else. I'm thinking that actually, what if you... Can I rotate you? There must be a way. There must be a way. No. There's a transform tool. Replace, replicate, select something. Oh, here it is. 90. Oh my god, it fits here. So maybe... Now I'm thinking if... this can go down, actually. This can totally go down. Like, this can be here. And now something I can do is... Oh, check this out. I can modify the pieces here in place. Okay, so how much I'm gonna bring it down? So something you can do is measure measure from here to here, and then be like 12. Oh, is that so? Is it 12? Yeah, 12. 12 point something. So what if but there's some little resistors here, so I wouldn't want to be messing with them. How about we go halfway, maybe 6. So something you can do here in assembly is right click apart and say edit in context. That means you are allowed to see how you made it and you can modify it here. Edit, and now the extrusion, I'm gonna do -6. Oh, it's not allowing me. -6. There we go. See how that looks. Okay, so the battery is there. I'm gonna go to assembly, and now this part, look, perfect, perfect, awesome. I'm not gonna constrain the battery. I think like that's fine. But yeah, I mean, I think we're doing a great job. Oh, something. Oh my god, I almost forgot. We need to have some little like towers going here and here that I'm afraid might make the battery go too close to the Arduino. So maybe we were right. Maybe we were right with having like the battery like there, because look, that's getting really close to the Arduino, and I just want a little thing here and a little thing here. Yeah, you know what? I'm gonna do Command C, Command C, Command C, Command C, Command C, Command C. Oh, but the part stays the same. All right, so I'm gonna go here, edit in context. And now the cool thing is that I'm always doing like operations here. So instead of the -6, I'm gonna just delete that part instead of. Why? Why not? Why not? Why not? It's just not addition. There you go. All right. So let's see. There we go. Okay, where we started. But now we know. Something cool we can do is well, you know what? This is enough for the tutorial. Oh, let's just finish the assembly. We still have time. So let's just bring the other part here. Insert case top. The cool part of designing things in the orientation that they're gonna end up in is that they appear like that here, so you don't have to rotate them. That's like a nice part. I'm gonna go into shade it. I like that better because I can select faces easier. And I'm gonna say, hey, make planar this with this. Say yes. Say yes, because I need to know. Oh my god, where did it go? Okay, that can happen. There it is. And then I'm gonna select this face and this face for another planar. Yes. And then, you know, I can click here, so I can actually like get these arrows, which help a lot. You know what? I'm gonna also do planar this face with this face. Planar. Oh, do it again. This face, this face. Yes. And now the cool thing here is that, oh my god, I cannot see anything. Well, you can always go to translucent. You can also click on a part, let's say this part, and you can click on this little eye to hide it. So yeah, I mean, but the cool thing is that you're now seeing how it's ended up without having to finish each part. Like, this is gonna help me a lot design many things around the assembly and how everything relates to each other. All right, so we're gonna leave the tutorial here, and then we will continue with just like details. Yeah, awesome. See you in the next one.